Okay, now we have already discussed about big O notation, how the sum has to happen. Okay, rule of sum, rule of product, how rule of sum and rule of product has been implemented using it during the bubble sort. Okay, this is how we have implemented. Like one is going from increasing order, then we are iterating through numbers from the second number, second year, third number to the number like with whatever it is coming out. So the each time the iteration is different. Okay, and here iteration is going from 0 to n, 0 to n minus 1, that means length of the array. So here we are calculating the sum of the sum, rule of sum, to calculate the sequence, sequence of instruction, how it has been calculated for the inner loop, how it is calculated for the outer loop. Okay, and how we converted that into a formula and where we got n squared. Okay, and similarly we have already also discussed about a recursive. Okay, recursive function also in this one. Okay, here the recursive Fibonacci series we have discussed. This is how, and it comes out to be o 2 to the power of n. This is because each time it is getting doubled. Each time the complexity, the growth rate doubles basically each time. So if you look at here, each time it is calling twice the same number being called twice. That is how it is going on, because you know that Fibonacci series is nothing but addition of two numbers, previous two numbers gives the future number. Similarly we calculate on this one. So well, let us go to some exercises I have put together. Just let us go through that one. One is like, for function is n as an integer. I have put the a query over here, the question over here, like for I is equal to 1 to n, then again nested loop for I is equal to 1 and to n. So n and n both are like directly we are putting across 1 to n and 1 to n. Definitely this 2 gives the n squared. But now just go inside this one. When Cij is equal to 0, then k is equal to 1 to n. Again we are putting k is equal to 1 to n. So what happened here? This is 1 to n, another is 1 to n, and there is another is 1 to n. So but these line items, if you look at these line items, these are sequences, and this is not dependent on number of inputs. It gives any input, it will execute once. If you look at Cij is equal to Cij plus Aik and Bkj, it will not execute again. When the number changes, then it will execute. So this is O1. This execution is O1. It is not dependent on number of inputs. Yes, the integer numbers like I has some value, j will have different value, k will have different value. Each time it goes through the loop. But by by increasing or decreasing this number, this particular line item will not take anything extra time. It is having a constant time, and you know that constant time is always declared as O1. So this is O1. So O1 into n, into n, and into n. So how much it will coming out? It is coming out to be n cube. Similarly, I'll go to the last one, because this is one we have done. This is a recursive number. When we are doing a recursive one, we have done this one earlier as well. If you look at here, recursive, little different we have done. We have made it less than 2. There we are making less than 1. So how much it is coming out? 2 to the power of n, exponential. This is exponential. So here it will will come out as a exponential. So n is an integer, and we go through this recursive series, then it will come out as a 2 to the power of n. Because if you look at here, recursive n minus 1 plus recursive n minus 2, that means this is nothing but a Fibonacci series calculation, addition of numbers. Okay, similarly we go to any number, like anything, like you can try out these two as well, the same thing. Like for I is equal to n minus 1, j is equal to I plus 1, k is equal to I to j. What is happening over here? I is equal to n minus 1 is like it is going through the number of iteration is almost towards the n minus 1 times. Okay, then it comes what? I plus 1 to n. So that it means each iteration it is different. For first iteration it will be 2 to n, then second iteration it will be like 3 to n, this third iteration it will be 4 to n. It is decreasing. Number of iteration will be decreased here, whereas here the number of iteration will increase. First time it will be 1 to 2, sorry, I is equal to 1, so 2 it will 2. Then I is equal to 2, I is equal to 2, j is equal to 3, so 1 to 3. Then I 1 to 3. So what it's saying? I is equal to 1, So it is 2 to n. When it is 2, it will be executing 1 to 2. When this becomes 3, it will become 3 to, okay, 1 to 3. When becomes 4, 1 to 4. When it becomes n, 1 to n. So this is increasing and this is decreasing order. Each time when it come, it is increasing, this is decreasing, and this is increasing. This is increasing based on this number. For example, when it is coming n by n minus 1, what will happen? N minus 1 is 1, right? So n minus 1 is n. N to n, that means once it will execute, it will go inside 1 to n. So it will execute n times again. It will execute n times again. So this is n. So it will be like, each time when you go through this second loop, this third loop or nested, the inside loop will go through all the numbers from 1 plus 1, 1 plus I plus 1 to n. For example, it is I is equal to 1, then it will be I plus 1 is 2, 2 to n. So 2 to n, each time this number increases, it will run that many times. So what will happen? 2 to n is like 1 to 2, then 1 to 3, then 1 to 4, then 1 to 5, then n to 6, then 1 to n. Then it will complete. Then it will go back here. Okay, this is done. So it is done here, and n is done. Then it will go back to here. Then it is 2. It will come as 2. So 2 to n. So each time it will come 2, 1 to 2, 3, 1 to 3, 4, 1 to 4, 5, 1 to 5, n, 1 to n. Then it will go back 3. So this thing is, if you calculate this, the similar way, if you calculate, it is not exactly similar way, it is only nested loop. If you calculate this one in a similar manner, it will come somewhere around nq. Again, this will be nq. Similar way, this is also nq, but this is a direct multiplication of three loops nested. But here the calculation should be different, because the iteration is, one is increase, one is reducing, and another is increasing. So both the cases we have to take care of, and we should calculate. And at the end, if you calculate, it will look like this. It will come like this: twice, two times execution, three times, four times, five times in one. Then it come three. Then when we become like I is equal to 3, then 3 times execution, 4 times. So it will coming reducing, right? It comes reducing that number each time. Okay, but here the loop is increasing. Here is a increasing loop. If you look at, twice it is execute, thrice, 3 times, then 4 times, then 5 times, like that. Here, this one will be executed two times, three times, four times, five times, when I is equal to 2. Similarly, when I is equal to 3, here it is 3 times, 4 times. So 3 to 10 times this will execute. But here it is decreasing, because the iteration will be, first time is be 2 to n. It will go through 2 to n times. When it next time will come, it will go 3 to n times. Then 3 will come, then 4 to n times. Then 5 will come, 5 plus 1, 6, 6 to n times. So it is reducing. The number of iteration for this loop is reducing, and this loop, each time it is increasing. It goes to 1 to 2, then 1 to 3, then 1 to 4, like that. So if overall we calculate this one, this will come again to NQ, NQ of the condition. Whereas here it is 2 to the power of n. Similarly, you can find out how it will be, how much the time taken, or the effort of, or big O growth rate of this particular function. You can find out that. Okay. Similarly, we have another one here, like, I have given another example, like, consider the following function of n. This is the function. Okay, so when it is n square, one is n square plus 100 on the 100 n is equal to, when odd it is n, when even it is nq. Similarly, we have given. So for distinct pair of ij means this I, f1, f2, f3, f4. Okay, distinct pair of I and j, fi and o, fjn. So these two, f1, f2, are related like what? It is like a o, big O, or big omega. If you look at, let me give an example here. Take this example. Let me just expand it a little bit. Okay, fine. F1 and f2. Take f1 and f2. So F2 is 1001 n square. So 1000, and this one O, if when you go to calculate for the O1, it will be 1001 n square, where C is 1001. In this case, F1 big O, that is F1 of f2 n for every n greater than 0, because f1 is less than O f2 n. It is always less than this one, because f1 is less than this one. Each time you put any number over here, okay, you put any number here, and n square is n is equal to 2, n is equal to 4, it will definitely less than 1001 and square. But if you reverse this, you go from f2 to f1, then what will happen? If it is f2 and f1, then f2 is big omega of f1, because f2 will be bigger than f1. That is how it is. The tn, you can say that this is tn and this is on, okay, ofn. This is ofn, this is tn. If this is tn, this is ofn, this is less than this. Okay, but if it is if this is tn and this is fn, then this is bigger than this. This is always bigger than this. When this is bigger than this, that is called big omega. Notice big omega. Okay, then let us take another example, f1 and f4. f1 is less than or equal to cf4 for n is equal to less than or equal to 100. Okay, as for constant, c remains more than n. It means c should be 100. C should be 100, right? For any C more than 100, it will remain as F1 is big O of F4, F4, where n is greater than or equal to less than or equal to 100. Once n becomes 100, more than 100, F1 is less than F4. F1 is less than F4, because when it is more than this, F1 n square is less than n cube. F1 is less than n. But if you make c is equal to 1, okay, in this case, let us make c is equal to 1. Then f1 is omega of f4 for all n less than 100. Okay, so remember this one. The tn, so if whenever, okay, let me put this one. Omega and big O. Let me write down this so it will be easy. This is big O. So calculate. This is same way when you write. Let me take that same thing. Better to take from here. Tn is big omega. So best case. Okay. So if you look at here we are saying, right. So if c is equal to 1, for example, f1, that is n square, is f1 is big omega of f4, big omega, because it is n for n is less than 100. If less than n is less than or equal to 100, tn will remain this one. So this will be this one. However, when c is equal to 1, when c is equal to 1, what will happen? When c is equal to 1, gn is nothing but n, tn is n square, so n square will remain bigger than this. Got it? Then it comes to, we'll try this one. But if c is equal to 100, if c is equal to 100, okay, what will happen? 100 into n. So you take any number here over here, 100n is always bigger than 100n is bigger than n square. That means tn is less than, tn is n square is less than 100n. For example, n is equal to, for example, 10. 10 into 10, 100. So here it is 100 into n. N is equal to what? 10. 100 into 10, 1000. So 1000 is bigger than this. So this is less than this. So when c is equal to 100, when c is equal to 100, then f1 is less than or equal to f1 is less than or equal to f4. F1 is less than or equal to f4 for all and less than or equal to 100. This one. On this case only. Okay. In this case. When n is greater than 100, of course, for any n, for any n, where is written? Okay. Here I have written this one. Once n is equal to 100, more than 100, then f1 will remain always less than f4, because f1 is n square, f4 is n cube for any n greater than 100. That's why it will remain. So this will be big O. This will be big O. This will remain big O. Whereas if you take 100, then only in this case, okay, c is equal to 100, then only this will be, it will remain f1 big O. Sorry, f1 is less than f4 when n is, for every n less than or equal to 100. As the constant c must remain more than n, it means it should be, c should be 100. So for any c more than 100, it will remain as f1 is big O of f4, where n is less than or equal to 100. So for c is equal to 100, you can write it down. For c is equal to 100, f1 is always, sorry, f1 is always less than or equal to f. It will always remain like this. There is no way that this will be more. So only when it is c is equal to 1, when c is equal to 1, f1 is omega of f4 for all n less than or equal to 100 in this case, because this is n square and this is n. Okay, this is what your explanation. If you have any question, you can write down to me. I will explain you again, but this is how it is as simple as that, that because it is n square and this is n, if it is 100 and c is equal to 100, then 100 and then for all n less than is equal to 100, n square will be less than n. That is what is big O. But for c is equal to 1, for all n less than or equal to 100, n will remain less than n square. That means n square will always be greater than n. In that case, it is omega, big omega. Whereas in this case, n is greater than 100. Once n is becoming greater than 100, then this n square is always remain less than n, because it is n less than n cube. That is why this n square, that is f1, is big O of n cube or f4. F1 is big O of f4. That is what we are discussing over here. Okay, so let us conclude here.